Good afternoon, everyone, and welcome to the NITheCS Micro-school. My name is Dean Brand. I'm a third-year PhD student at Stellenbosch University, working under the supervision of Professor Francesco Petruccione, who's the director of NITheCS. Today's micro-school is focused on an introduction to GitHub Actions, which is building upon the previous micro-schools of Git and GitHub. So hopefully it'll be an exciting expansion on that. Today's speaker is Shane McFarthing. You can see on screen now. He is a second-year PhD student in physics, also at Stellenbosch University, also working with Professor Francesco Petruccione and Professor Elias Anaiski. His research is focused on the development of quantum algorithms for applications suited to noisy intermediate-scale quantum devices. He holds a Bachelor of Science and a Master of Science in Computer Science, which he completed at the University of KwaZulu-Natal. And yeah, very experienced in programming and coding and using GitHub and GitHub Actions. So he's a perfect person to be presenting this topic to us today. With that, I hope you enjoy. And Shane, I hand over to you.
Thanks for the introduction, Dean. Let me just share my screen. Okay, can you see the presentation?
Yes.
Oh, perfect. So yeah, as Dean said, today we're just going to be taking an introductory look into GitHub Actions. It's a nice feature that's available in GitHub, and I think that it builds quite nicely on the previous micro-school that Dean gave. So just to kind of give the context of this presentation, it covers a lot of the stuff. Well, it doesn't cover, again, what Dean has already covered, but just to give the context of it is that we're working with mostly version control, right? So I think almost everyone who's attended is developing some sort of code, and you've all run into the problem of developing different versions of it, needing to make updates, changes, add new features, and it can become a bit difficult to manage all of that. I mean, the rudimentary way would be you have your code on a USB and you keep a local copy of it. And then if your friend wants to work on it, you give him the USB, and very quickly you realize it's not an efficient way to work. And it becomes quite problematic if you need to go back because you change something, something's not working. And Git gives you a very nice and efficient way to manage the versions of your code. It helps you to basically track everything that you're doing. It has very nice operations for combining different versions of your code, for going back, doing tests, stuff like that. And GitHub is used to make that all available to collaborating on your code and hosting the repository of code that you're working on. And I think it's actually seems quite common these days that most people's interaction with Git comes through GitHub first. That's what they're first familiar with. So they're very, very useful tools. They're used in almost any job where you're going to be doing code development or research with lots of people. And today's talk is on one specific feature that kind of builds on the automation abilities of GitHub a bit further past the normal operations that Dean covered in his previous micro-school. So the GitHub Actions gives you a platform for CI/CD in GitHub, which is continuous integration, continuous development, or deployment. And what that is a philosophy that's used very often in software development, where you're continuously integrating changes that you're making in the code and performing tests so that you're trying to minimize the amount of issues that can arise. And then what that can try to prevent is, that case where someone gives you code and the code doesn't work, and then they say, oh no, but it worked on my machine, and then it creates this thing where it has to go back and you have to test it. And what continuous integration is doing is frequently merging your code update onto the repository or whichever branch you're working on so that issues that arise are very quickly identified. And then continuous deployment is making the code readily available for release to users. So through the efficient use of CI/CD, you can kind of speed up the development cycle, make it so that if someone wants to use your code, you don't have to say, wait, please wait for me to kind of wrap everything up for you, because you're generating versions for them to use as you go. And GitHub Actions allow you to automate this kind of procedure. You can automate the building of your code if you're generating executables or something like that. It can automate the testing and the deployment. And essentially, it's like the name would suggest, it's actions that are performed, and these actions are triggered by certain events. and they can be triggered by a variety of events, and we kind of will go into them, what these can be. But essentially, you define what the action is that happens, and then it runs on a certain event that occurs. And the environment that it runs on is a virtual machine that can be hosted either by GitHub. They offer standard, it's called a runner. They offer standard GitHub hosted runners, or you can use your own locally hosted or self-hosted runners if you have certain requirements. But then, there's the added complexity of needing to manage that yourself. And then beyond just like the building and the testing, it's also very useful for automating certain housekeeping tasks. For example, if you're working on code and someone wants to raise an issue on GitHub, you can automate the labeling of that issue. And you can, if someone clones your code for the first time and they contribute to it, you can have a welcoming message to that person, welcoming to the kind of team of everyone working on that code. So the key point is that it helps you to automate actions that you would need to normally integrate manually. And by doing that, it allows you to make your process of development a lot more efficient and just a lot more stringent so that you're not making mistakes and you're following best practices. So the key concept within GitHub Actions is that of a workflow. And the workflow, it's a configurable automated process which runs one or more jobs. So it's like a script. You define it within a YAML file, and you have to place it in a certain place in your repository. So that specific location is within the .github workflows directory. And you can have multiple workflows, each defining different actions that need to happen. And they're all defined to run on certain different events. And the general structure of how all of this is happening is that you have an event that occurs, and based on all of the workflows that you've defined, certain workflows will be triggered by that event. And then those workflows are comprised of a number of jobs, and each job will run on its own runner, which is like the virtual machine that is going to be executed on. And by default, those runners the jobs are run in parallel. And each job has a number of steps on it, and each step defines something that needs to happen. So you can either have a certain script, a script that's going to be executed, or you could have an action. Sorry, whoever's mark is on, just mute themselves. It's a little bit distracting. Thank you very much. So yeah, you have the runners that are all happening in parallel, although you can introduce dependencies so that one job will wait for another job to complete. And each job has a number of steps that will be performed. The step can either be an action, which is a reusable component, or it can be a script that you can define. And we can go now into exactly what it is that make up those different pieces. So the first part is the trigger events. These are the things that cause the workflows to execute, and they can be defined as either events that happen inside the repo, like pushes and pulls and merge requests and things, stuff that can happen outside. It can happen at certain scheduled times, or they can be triggered manually. And these are defined in the YAML file for the workflow using the on key. So a nice example is just we have this case, it's on push. If you have this in a workflow, that workflow will run on the case of a push to a certain branch or to a certain repository. And you have some fine control over exactly which events. So you can have a class of events, such as like a push, and then you can further specify that you want the workflow to only run when there's a push to a certain branch, so that you can kind of delimit which events are triggering your workflow. And it gives you a lot of control over things. So you can create workflows for different cases that will run in certain cases, and then they'll only happen when you want them to happen. The next thing is the runners. So the runners are the environments that that each job will be executed in. And like I said, they're virtual machines that are hosted either by GitHub or by yourself. And there's various billable options, but if you have a public repository, then you get free unlimited use of the GitHub hosted runners. If you have a private repository, then there's some limit that's imposed. I think it's something like, I don't know, 20 minutes to an hour per month. I'm not exactly sure the limit, but essentially there is a limit. And then there are larger devices which have more CPUs, more storage, more RAM. Those they're accessible, but you have to pay for them. But for most jobs, you probably find that the standard GitHub hosted runners will be sufficient. And then like I said, so you have access to standard size ones with a certain number of CPUs and stuff like that. And then you need to specify what the operating system that you want that runner to be using is. So like for example, on the right-hand side, we use the jobs key to say that these are the jobs that are going to be executed in the workflow, and then we label them. So we have the first job, and then we say to specify the runner that job will be executed on, we say runs on, and then we can either give a single option or a list of options. So in this case, we say it's self-hosted Linux with the x64 instruction set and GPU. And it will run on the runner that satisfies all of these requirements and is also available. Otherwise, it will queue and wait for that runner to become available. So you have control over exactly what environment you're working in. You can use Linux, you can use Windows, you can use Mac. Like Mac OS, they also have certain, like you see, CPU architectures that are supported. And you can change that according to your needs. So the real meat and potatoes of the actions are the jobs that are going to be happening. So these are what you want the workflow to actually be doing. So each workflow has at least one job in it. And like you saw on the previous slide, you specify the jobs based on the jobs key, which is you have the jobs key is the outermost one. And then inside that, you'll have your different jobs that are going to be executed. And you can label them whatever you want. It just needs to start with either an underscore or a letter, and then it can only contain alphanumeric characters and dashes and underscores. So in this case, we just call it the first job, and then each job will have the environment that we want it to run on for the runner. So we say Ubuntu latest in this case, which is not the latest version of Ubuntu that's available. It's just the most recent version of Ubuntu that is supported in the runners that are hosted by GitHub. And then in each job, there's a number of steps that need to be done. So it's like I showed here, you have your runner as the environment the job is executed in. You have your job, one job per runner, and then you have your steps. So in this case, we have two steps, and we can see the dashes are elements in the list, our list items. The first one, we're going to name that step example script, and we show you how to run a script for your steps. So in this case, the vertical bar denotes that you're going to have a multi-line input. So that is, it's just a YAML syntax thing. And then the command we're going to run here is to install pip. Then in our next step, we have an example action. And in this case, we're going to use an action that is predefined and available on GitHub. So you have your workflows comprising multiple jobs, and then an action is a reusable like series of steps, and you can use those within your workflows. And the really powerful thing about GitHub Actions is that they're extensively used, and a lot of people have put a lot of work into developing reusable actions for a lot of different tasks. So if you're thinking, I want to do something that's a little bit more complicated, rather than just like a simple Python script, like installing pip or something like that, very often you can go onto GitHub. There's something called the GitHub Actions Marketplace, and you can kind of look for an existing action that does what you already want. And you can then put together a nice complicated workflow that accomplishes what you want, and it will use actions that other people have written, and they took the time to do that. So in this case, we're using this is anything that starts with actions / those are the ones that are actually created by GitHub. And in this case, actions checkout, it checks out a copy of your code or your repository, because the runner environment doesn't automatically have access to the code. So this is a very common action that you'll have to use if you want to perform any operation on your code or any processing. You need to check out the code so that it's available within the runner. And the way that you put all of this together to create a workflow is that you first have a name for your workflow. And this is how it will be labeled on GitHub. After this, I'll show you the interfaces on GitHub so you can see. But you name the workflow. You have the run name, which is the label that is put into the workflow run history. When this specific workflow runs, each time it runs, this run name will be used as the label. You could have like a variable in here. So with something like a timestamp, for example, so it would say running workflow example, and then your timestamp. And when you look at the history of the workflows being run, you can see what times they were run at. But those are just the naming conventions. And then we have the event, the trigger event, when we want this workflow to happen. So in this case, it's going to be on push events to any branch in the code. And then we have jobs. The series of jobs, in this case, we only have one, which is just called Explore GitHub Actions. It runs on a GitHub hosted runner that has Ubuntu environment, and it contains only one step, which is to run this command, which is to just print this in the terminal. So this is the basic example. But I'm going to show you ones that are a little bit more helpful. But before I do that, I'd just like to show you on GitHub how you can see these features. So I've created an example repo called Micro-school, and it contains only a couple files, like a file with some functions, a file with unit tests for those functions, and then you can see I have my directory .github workflows. And I have 2 workflows defined within this directory, and I'll go through them with you. But if I just go back, so this is on the main page, you see at the top, there's a tab for actions. So if we go on there, it shows you all of your workflows. Here, these are all the workflow runs. And on the left, you can see all workflows or the specific 2 that you've defined. So it uses that name. So if I go here, you see how like you specify the name. The name that you give the workflow is what will pop up on the left. So I have my 2 workflows that I defined, and they have these names. One is to run a linter on my Python files, which checks the syntax and stuff like that and makes sure that my coding is consistent and follows good practices for the language that I'm using. And then you have run unit tests, which is very useful for testing your code. If you make a change and you have some tests, you want to make sure that your change didn't break everything, and you can automate the running of the tests. So you can check the specific workflow that you're using. And then there's also some, not diagnostic, but some cool metrics. So you can go here and see your actions usage metrics. So this past month, I've used 48 minutes. I've done 48 job runs. It's broken down into which actions there were, how many minutes each one used, how many runs were performed for each, how many jobs, and the runner type and the runtime OS. So you can get quite a bit of information about the specific actions that you're using. So now if you want to create an action, I'll just switch to VS Code for this. Make sure that it's big enough for everyone to see nicely. Okay, so I'll just quickly show you the example repository. So I have the utils.py file, which is a module containing some simple functions. I have an add function that returns the sum of 2 numbers. I have divide, which returns the quotient of the 2 numbers. I have multiply. Give me 1 second, actually. I'm on the wrong branch. Okay, so the original version, the main branch, it has only 3 functions: divide, add, divide, and is palindrome. So this checks that whether a string that you provide is a palindrome or not. I then have a test file, which has some unit tests that use the PyTest package. And these just check that my code works for certain cases. So we have the case where it checks that add works like in a straightforward way. We have the quotient test. We have the test that it raises a value error when you divide a number by 0 with the division function. We have the check for the palindrome function. We have a check where the palindrome is false. And then there's another way you can parameterize the testing using pytest.mark.parameterize, and it will run the test with each of these words. So these tests are written to test my code. If I show you, like, a normal thing, you would write your tests, you would import pytest, and after installing the package, you'd say, oh, I want to test my code. I can just run pytest. like this and say, okay, cool. All 8 of my tests passed and it took 0.01 seconds to run. But you can automate this so that rather than having to do it manually, you can have it be a workflow that will run every time you do a certain action. So if I take a look at my workflows folder, which is in .github workflows, you can see I have my 2 workflows. The first one I'll go through is run tests.yaml. And in this workflow, I have the name, run unit tests. I have the trigger event that I want to define for this workflow. In this case, I want it to run on pull requests, and specifically when a pull request is opened, with the target branch being main. So you have some ability to dictate exactly what. So these are event types. So within this trigger event, there's an event type for a pull request was opened, and then I can specify the branch with main. Sometimes tests can take long to run, depending on how many you have and how involved they are. So maybe you would want your tests to only run on pull request, which I've just what I've defined here. There might be another case where you want them to run every time you push code, in which case you would just say on push. So then we've defined the trigger event, and you want to take a look at the jobs that are going to be run in this. So we have the jobs key, and then it contains only one job, which is called test. And test runs on the Ubuntu latest environment in a runner and has a few steps. So the first step is that it will use this actions, this GitHub checkout actions or action. And like I said earlier, that's because if you want to do anything with your code, you need to check out a copy of your repository in the runner environment. So we'll do that first with this step. And then after that, we'll set up a Python environment on the runner machine as well. So there's another predefined action for that, called actions setup Python. These parts of the line denote the version. So that when people are creating actions, sometimes they'll update them and then they'll release different version numbers. And to specify which one you want, you should use the version to denote the specific one. And some actions take inputs, and you can define the inputs using the with key. So in this case, setup Python gives us the option to specify the Python version. So I'm just going to say use Python version 3.10. And at this point, our code is copied onto the runner machine, and Python is all set up for us to use. So we need to install pip, which we do here. And then we use pip to install the PyTest package so that we can do our testing. And then the last step is to simply run PyTest. So you can see like the goal of this workflow is to run PyTest to do unit testing on our code and do it automatically. And then each step defines all of the steps you need to do to accomplish that task. And like you can see, you can use other people's predefined functions to accomplish this. And if I show you how this works, so like I said, it runs on pull requests to a specific branch. So I cut a feature branch from the main branch. If I just go check that out, you can see that the only small change I made was I added this other function, multiply. And then I added a corresponding test for that. And I've pushed these to this branch. So now if I want to open a pull request to merge my feature branch onto the main branch, then that unit testing should run, right? So if I go to my GitHub repository and I go to pull requests and I say open a new pull request and I choose, well, I don't have to choose, the target is already main, and I can change the source to feature branch. It will then throw the changes, and I'll say create pull request, so create one. And then if you look over here, you can see there is a test waiting. So queued, it's a unit test for my code that's going to run. And that's for the workflow that we just went through. So we can wait for it to run, and then it should succeed. So yeah, you can see it was successful. And the reason there's other run histories here is because just while preparing for the mini school and making sure everything works nicely, I opened the pull request a few times and it ran the test in each of those cases. And the workflow running is linked to the specific commit hashes in your code. And if you make a pull request, it will run with the workflow that I had, it will run the test. And then if I closed the pull request, did some other changes, and then opened another pull request, those commits are still included in the commit history. So it will show the history for the tests that were run. And now the test was successful. I can say, cool, confirm merge. This will merge the change that I made onto my main branch. After doing that, I can delete my feature branch because I don't need it anymore. And if we take a look at the actions, you can see, okay, the one we ran was unit tests. And we can see here, it ran a minute ago. It was successful. We take a look at how it's working. And you can see, okay, cool, that worked. The only job that was there was the job test. And it has all the different things that were done. And if you go into it, you can see the specific steps, like the things that were done in order to set up that action or that workflow run. Now, if we go back to the code repository, I'll go back to main. And now update main by pulling from the remote version. So then that should pull in the multiply function. So now I'm on main, you can see multiplies there. And that was an example for the unit testing. Another useful thing that you could do is you could lint your code. So like I mentioned, linting is useful for making sure that you're following correct syntax. I've defined this workflow called run linter on Python files, and this one runs on push. So if you push a commit to the remote branch, then this workflow will be triggered. It contains only a single job called lint, and it has a single step. And this step is to do linting using another predefined action, but it's one that a user on GitHub has defined. So the way that you can find these kind of actions is if you go to your code, just go to your workflows. Let's say, in this case, what I would have done is I would have opened a new one. I would have made a new workflow, but I have an existing one, so I can just open it up again and show you what happens. When you create a workflow, you have your editor open here, and then on the right-hand side, it opens up what's called the marketplace for actions. And this has all of the different actions that people have defined. They have different categories. A nice thing or feature about GitHub Actions is that depending on the code that you have in your repository, it might also suggest certain actions for you in whatever language you need. So for example, there's JavaScript ones, so there's ones for different languages. And I wanted to lint my code. So I typed in pylint, and there were quite a few different options. And I just selected the one that had the highest rating. So that was this pylinter. And then you can see here it says to install, copy and paste the following snippet into your YAML file. And this is a step. So I copied that, pasted it in here, and that's how we got this specific user-defined action, which will lint my code. So that's how I created it. If I go back here and I say, okay, cool, I want to test how this works, then I need to make a change, make a commit, and then push that to a branch. So easy one here, just for today's sake, just say update to the doc string. So I will simply push a change to the doc string for the test module. I'll just say here, give a commit message, update the doc string for testing of workflow, because we're going to see that it actually triggers it. So just if I go back to my actions tab, we know that we're going to be running the linter, so I can specifically look at that workflow, and you see that the last time it ran was 4 minutes ago with the pull request. So let me go back. I will now push my commit to the remote version of main, wait for it to succeed. Now I go, cool. It should have started running the linter workflow. So I just refresh the page and we can see that it did. And because I didn't specify a name for the run, it uses the commit message. So we can see it's busy running it and it's in progress. I'll go into it while it's running. We can watch how long it takes. I think this one takes about 30 seconds to do. And you just wait for it to succeed or to fail, depending on the status of the stuff that it's checking. So in this case, it succeeded. And you can see it set up the job on the runner. It had to build the function, the action that I was using from the other person from the marketplace. And then it ran their action. And then it completed the job because the linting was successful. So those are some very basic examples of how you can use actions to automate certain things, but it's really, really powerful. As you've seen with these workflows, so go to the test one, you can compose a whole bunch of different things that need to happen. So if you are working on a big code base and you're generating images that run on like containers, like Docker images or something, then what you can do is you can automate the building of them at certain points. Like let's say you want to generate a release, you can automate the building of that, and then it will link it on GitHub, and you can really do whatever you want to do with these and just combine them. There's a lot of different options for each of the steps, and what I mean, like each of the different components of the workflow. You can set a whole bunch of different events for this to run on. You can have a lot of filters for which events you want to have them happen on. You can change the runner environment for each job. Like I said, the jobs run in parallel by default, but you can specify that the one job should wait for another one by using the needs key. So you say test needs test 2 or something. And that way you can kind of control how the jobs are being executed. And this shows that there are a lot of features on GitHub that we don't normally delve into, but they're very useful. And if you take the time to try to learn it, then you can probably find really cool and efficient ways to do certain tasks. Like I said today, I just went through a very basic example and just kind of introduced the concepts to you. But if you just type in GitHub Actions on Google and you click on the first entry, which takes you to the GitHub website, it explains stuff for you and you can say get started. And then there's a nice guide. So it goes everything from how to write workflows and an introduction of when workflows run, so trigger events. So like I said, I only went a little bit into it, but there are a lot of trigger events that you could specify. Don't even know a lot of them. There's so many. So if you want to learn a lot about it, then probably just come take a look at the documentation on GitHub's website. Yeah, thanks. Yeah, that's everything.
Yeah, thanks, Shane. That was really interesting to see. Yeah, really cool to see how nice it makes the whole process of whenever you're interacting with the code, how it automates a lot of the boring steps that you'd have to take afterwards. It's really cool to see.
Yeah,
I know I'm going to start using it kind of immediately.
that's
So
great.
yeah, thanks again. I see there's
It's a pleasure.
one question sorry, in the chat asking, do you have to specify priority for your run tests if more than one person is working on the project? So if there's multiple pull requests, do the tests run concurrently?
Yes, they do. So like I said, the workflows will also you'll have a specific branch. So typically what would happen is if you're collaborating on code with somebody and you have a code base, so let's say in this case was your main branch, and then you guys split up the work between yourselves and you said, I'll do this, you do that. What you would do is you would each cut your own branch. So you'd say like the names Alice and Bob are often used. If Alice is working with Bob, Alice will cut a branch and it'll be Alice's branch, then Bob will do the same and it's Bob's branch. And then when you do the pull request, the workflows that run are the workflows that are specified on that branch, the one that you developed, not on the branch that's the target for the pull request. So if you guys both submit a pull request at the same time, they will generate independent workflows that are running. And those will run then depending on the runner environments and the availability of the resources. And if you update a workflow on your branch that's not reflected on main, when you push, it will use the workflows that you've updated. When you do a pull request, it will also use your updated workflow. And there are some ways to change which workflow versions are used, but I'm not exactly sure how that happens.
Okay, thanks. Yeah, it does clear things up. For me at least, I hope it does for the person who asked as well. I was also quite curious to see to ask about how easy it is to integrate with something like Docker, but I'm glad that you mentioned at the end there that it is quite simple.
And yeah, definitely. So like what some software companies will do is when they have like the Docker images that they use to distribute their code, they then part of the CI/CD process is frequently generating releases. So like either for bug fixes or feature updates or anything like that. And you can automate that to happen, but depending on certain flags that you can give it. And it works very well for building Docker images. Something else is that I mentioned the actions that you can use. So GitHub has some that are available and other people have also defined them. And if you want to make your own actions, you can. They go in a different directory called GitHub Actions rather than GitHub Workflows. And you have to define them to run either in a JavaScript environment or in a like containerized environment like Docker. And so I didn't show that today. It's a little bit more involved, but you do have freedom to make your own actions.
Okay, that's very interesting and perfect for starting point for us in the micro school to go and look further into documentation because it looks like it is very well documented and lots of explainers online. So very good to see this. Thanks so much. Are there any other questions in the chat? Then you can feel free to ask it now. But I imagine that might be all of the questions for now. I think everyone's excited to get started with it. But if you do get started with it and have questions later, this recording will be on the NITheCS YouTube page within the next few days. So we can ask questions in the comments there and we'll be sure to get to them. But with that, I think that wraps everything up. So thanks again, Shane, for presenting. Yeah.
It's a pleasure. Thanks for giving me the opportunity. Okay. Thanks, everyone.
Bye, everyone.